Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning. So for the last couple of weeks, we've been establishing a fundamental principle of geology, that major geological events, earthquakes, volcanoes, mountain building, tend to happen at the boundaries where tectonic plates meet. But nature loves to break its own rules. Today, we're going to talk about a major exception: hotspot volcanism. A classic example, and the one you're probably most familiar with, is the Hawaiian island chain. Hawaii is a string of volcanoes sitting right in the middle of the Pacific Plate, thousands of kilometers from the nearest plate boundary. So how is that possible? The answer lies deep within the Earth. A hotspot is a fixed place in the mantle, the layer beneath the Earth's crust, that is exceptionally hot. This intense heat causes a plume of molten rock, or magma, to rise up and burn through the tectonic plate above it, forming a volcano. The crucial thing to grasp here is that the hotspot itself is stationary. It doesn't move. But the tectonic plate above it non-stot grisators. Imagine a piece of paper. That's your tectonic plate. Now, imagine holding a lit candle, your hotspot, underneath it. If you slowly drag the paper over the flame, you'll get a series of burn marks. That's exactly what happens with the Pacific Plate and the Hawaiian hotspot. As the plate drifts to the northwest, the hotspot creates a volcano. The plate keeps moving, and that volcano is carried away from the hotspot, becoming extinct. Meanwhile, a new volcano forms over the hotspot. This creates the chain of islands we see today, with the oldest islands to the northwest and the youngest, currently active one, the Big Island, sitting directly over the hotspot. And it's important to distinguish this from the volcanism we see at plate boundaries. That process is about plates crashing together or pulling apart. Hotspot volcanism is about a deep, fixed heat source punching through a plate, almost like a blowtorch. And these hotspots aren't just in the ocean. Yellowstone National Park is another famous example, but it's a hotspot situated under a continental plate, which results in different kinds of volcanic features, like geysers and massive calderas.
Listen again to part of the lecture. Then, answer the question.
And it's important to distinguish this from the volcanism we see at plate boundaries. That process is about plates crashing together or pulling apart. Hotspot volcanism is about a deep, fixed heat source punching through a plate, almost like a blowtorch.
For more TOEFL mock tests, as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.